Hello everyone. Welcome to week 2 of this 18-week Artificial Intelligence Fundamentals and Applications program with AI. Last week, we laid the groundwork for our journey into artificial intelligence, exploring the basics and the intricacies of neural networks. We delved into the biological and artificial aspects of neurons, understanding their communication and the architecture of neural networks. Today, let's recap and delve further. We began by discussing the artificial brain's training process, drawing parallels with our biological counterparts. The lecture introduced the concept of neural networks, both in the context of biology and AI. Our focus then shifted to a practical application, linear curve fitting. We explored how AI can determine the internal resistance of a battery, experimentally. The neural network learned to find the best fit straight line for the data, showcasing the process of curve fitting or regression. We discussed the training process, error functions, and weight adaptation, shedding light on the optimization methods employed. In the learning types, we covered supervised learning, where AI is trained using input-output pairs, and reinforcement learning, likened to learning from rewards and penalties. We touched on unsupervised learning, where AI discovers patterns without explicit guidance, mirroring our exploration of new areas without a trainer. In today's class, we're set to dive into the essential principles of programming for artificial intelligence. We'll be uncovering the foundational aspects that form the backbone of writing code for AI applications. This session is designed to provide you with a solid understanding of the programming basics that are crucial for working in the fascinating field of AI. Let's start our session. Introduction to Python. Python is a versatile and powerful programming language that has gained tremendous popularity in various fields, including artificial intelligence, data science, web development, systems automation, and many more. The rise of Python libraries such as NumPy, Pandas, TensorFlow, and PyTorch further solidified its position as a go-to language for cutting-edge technologies. Variables. We learned that neural networks receive input data or information for processing. Let's assume we input information about a person as follows. Name, Mike. Age 25. Height 1.78. Dubai resident true, yes. As you can see, there are many different types of data. Name is a word, age is an integer number, weight is a decimal number, and Dubai resident is Boolean, true or false. In Python programming, different types of data are identified as variable types. String variables. Name of a person or a city. Integer variables. Number of students in a classroom, age of a person. Float variables. Height of a person in meters in decimal points, the temperature in decimal points. Boolean variables. Dubai resident, true or false? Yes or no? Understanding variables in Python. What you see here is the JupyterLab Notebook. It is a web-based interactive development environment for code and data. In this notebook, we'll learn about variables used in Python programming through simple examples. Variables are like containers that hold different types of data. Storing different types of data. In programming, variables allow us to store and work with different types of data. First, let's look at how to store a string variable. In this code, the line starts with a hash is a comment. Comments are lines of text meant for human readers to provide explanations, clarifications, or notes about the code. We stored a string variable in a variable called name. The name is enclosed in double quotes because it's a piece of text, or a string. The print function is used in Python to display the text or values you provide within the parentheses. To execute the code, you can either navigate to the top of the ribbon and click the play button, or you can simply press the Shift and Enter keys simultaneously within the code. In the above code, we stored an integer variable in a variable called age. Note that quotes are not used when storing an integer variable. The same applies to float variables such as height in meters. Here, we stored a float variable in a variable called height. The height in meters is a decimal number. Such numbers are called floating point numbers or float. Lastly, we stored a Boolean variable in a variable called do_by_resident. We used the value true to represent yes. In programming, true and false are special values called booleans. Using f-strings. In Python, we can use f-strings to create dynamic strings that include variables' values. In the code, we used an f-string to create a sentence that includes the values of the name, age, and height variables. The curly brackets placeholders are replaced with the actual values when the string is printed. The type function. The type function is used to determine the type of a variable. In the code above, we used the type function to determine the types of the variables we assigned earlier. The function returns the types of the variables as outputs. The input function. The input function is used to get the input from the user. The input is always taken as a string value. The prefix appears when we print the name, because we're using a Jupyter notebook to get user input, and it's showing us the result of a special operation performed by the notebook. We can avoid it by using await input. Let's use it and print it, and see the difference. Now you can clearly see the difference. We will use await input hereafter to take the input. Containers. A short while ago, we used information of a person. Assume we want to handle information about several persons at the same time. For such purpose, we can use three functions, namely lists, tuples, and dictionaries. Lists. A list is an ordered collection of items. Let's explore some common list functions. This code stores the names of the members of a team in a list called names. Here, we have used square brackets to create the list. Individual name is entered within single quotes and separated by comma. Now let's see how to add a new element to a list. This code uses append function to add a new name, Jennifer, to the existing list, names. Now let's see how to remove an existing element from the list. In this code, the function remove removes the name Charles from the existing list, names. Let's say we want to display a particular name in the list. For example, the third name. This code displays the third name in the list. Index 0, 1, 2, 3 correspond to the first, second, third, and fourth items in the list. Hence, print names 2 code prints the third name. Sometimes, we need to check whether the name of a particular person exists in the list. Following code checks whether Donald is present in the list. This code prints true if the name is present in the list, and false otherwise. Hence, the code print Donald in names prints true. Tuples. As mentioned before, tuple is similar to a list, but it's immutable. A good example is the birthdays of the team members. The following code saves the dates of birth of the team members in a tuple called DOB. Here, the tuple is created inside the parentheses. Individual date of birth is entered within double quotes and separated by comma. Unlike lists, which support methods like append and remove, tuples do not have methods to modify their contents. Now let's see how to check the number of elements in the tuple. This code prints the number of elements stored in the tuple. Len DOB function retrieve the length of the tuple. Dictionaries. A dictionary is a collection of key-value pairs. Here are some common dictionary operations. Now let's store all the information of a person in a single place. This code stores the information about a person as key-value pairs, where keys like name, age, and DOB label respective values such as Michael, 25, and 5/4/1998. Now let's see how to access a particular piece of information in the dictionary. For example, the full name. This code displays only the full name of the person. Let's see how to add a new piece of information to the dictionary. The following code explains how to add the gender of Michael into the Michael_info dictionary. Sometimes, we need to check whether a particular piece of information is present in the dictionary. The following code demonstrates how to check the age key-value pair is present in the dictionary. In this notebook, we covered some of the most commonly used functions for lists, tuples, and dictionaries in Python. These functions are essential for effectively manipulating and working with different types of data. Arithmetic operators. In Python, operators are symbols used to perform operations on variables and values. Understanding different types of operators is essential for writing effective and functional Python code. Let's explore various types of operators and how they are used in Python programming. Arithmetic operators are used to perform basic arithmetic calculations. Here are some of the common arithmetic operators in Python. Addition. Add two operands together. The following code can be used to add two or many numbers. We use the plus operator, as usual, to add two or any number of variables. We will use a wait input to get two numbers from the user. As we know, the input is stored as string. We need to convert it to integer to perform arithmetic operation. In the following code, we use int function to convert the input string into an integer. Subtraction. Subtracts the right operand from the left operand. In the same code, by replacing the plus operator with the minus operator, we can perform subtraction to obtain the difference between the two numbers. Multiplication. Multiplies two operands. In the same code, we can use the asterisk operator to obtain the multiplication or the product as follows. Division divides the left operand by the right operand. The division operator, slash, divides the number on the left by the number on the right. Modulus returns the remainder of the division between the left and right operands. The modulus operator, percent, returns the remainder of the division. In here, 10/5 is equal to 2. And the remainder is 0. Exponentiation raises the left operand to the power of the right operand. The exponentiation operator *** is used to determine the power of a number. Following code evaluates x to the power y. Try changing the x and y and run all the operators. Conditional statements: if, else, else-if. In Python, the conditional statements are used to make decisions based on conditions. It executes a specific block of code if a certain condition is true, and an alternative block of code if the condition is false. Before moving on to conditional statements, it is important to understand the operators such as equal, less than or equal, etc. Note that the operator equal is used to assign a value to a variable. The operator double equal is used to compare the values of two variables. The less than operator indicates that the value on the left is less than the value on the right. For example, 10/20 means 10 is less than 20. Alternately, 20/10 is read as 20 is greater than 10. The operator is read as less than or equal. For example, is read as marks is greater than 60 and less than or equal to 75. The following code requests the user to enter his or her marks and stores the entered marks as a variable marks. The following code prints, unfortunately, you are required to resit for the exam if the entered mark is less than 40. Else, it prints, you have satisfied the minimum requirement. If multiple conditions are involved, we need to use else if as follows. As we can see, the code starts with if and ends with else. In between, there can be any number of else if statements. The following example demonstrates the use of double equal operator. This code prints, system is marginally stable if the z value you entered is exactly equal to 1. Loops. If you want to repeat the same task again and again, loops can be used. Looping structures execute a block of code repeatedly. For loop. In Python, for loop is used to iterate over sequences such as lists, tuples, string, etc. While loop. Imagine you are supposed to find the sum of the first 100 positive integers. You can go as 1 plus 2 plus 3 plus all the way up to 100. It clearly is a tedious task. With while loop in Python, all it takes is code of few lines. Python while loop is used to run a block of code repeatedly as long as the defined condition is true. Example. Iterating over a list. The for loop is used to repeat an action multiple times. Let's see how we can use a for loop to print each mark in a list of marks labeled marks list. In the code above, we have used a for loop to iterate through each element in the list, marks list. The code assigns values in the list to the variable marks, and prints it iteratively every time the loop is repeated. The loop terminates automatically once the list is completed. Example: iterating over a string. The for loop can also be used to iteratively print each letter in a string, as demonstrated in the following example. Now, we will take a look at some examples where the while loop is used to repeat the task until a condition is met. Example: printing the first 10 positive integers. The following simple code prints the first 10 positive integers. The index I is initiated as 1 and repeatedly increased by 1 and printed. This task is repeated as long as the condition I less than or equal to 10 is true. That means the loop stops after printing 10. Example: sum of the terms of a series. Imagine you have to sum up the terms of a long sequence of numbers as follows. Doing this manually can be a tedious task. Consider the following series that starts with 3 and increases by the step size of 2. 3 plus 5 plus 7 plus 9, all the way up to 15. The following simple code prints the sum of the elements of the series that starts with 3 and ends with 15. The index I is initiated as 3. The loop iterates over the range 3 to 15 with a step size of 2, add the current value to the sum variable. This task is repeated as long as the condition I less than or equal to 15 is true. Finally, the sum is printed. Functions. A function in Python is a set of codes written to perform a specific task. Hence, instead of writing lengthy codes to perform complex tasks, we can directly use the functions and save time. Python has thousands of its own functions, such as sum, to sum up the values in a list, len, to determine the length of a list, etc. Sometimes, we would like to define and use our own functions in Python. Next, we define our own function to determine the average of the values in a list. Then we can use it by calling it wherever required. Calculating the average using a function. In this notebook, we will explore how to define and use a function to calculate the average of a list of numbers. Defining the average calculation function. Let's start by defining a function named calculateAverage that takes a list of numbers as input and returns the average of those numbers. Let's break down the code step by step. Def, calculateAverage, numbers. Def, this is a keyword in Python used to define a function. CalculateAverage. This is the name of the function you are defining. It can be any name you choose. Numbers. This is the parameter list, enclosed in parentheses. It's like a placeholder for the data you will provide when you use the function. In this case, the function expects a list of numbers as input. Total equals some numbers. This line calculates the sum of all the numbers in the provided list. The sum function takes a list of numbers as input and returns their sum. The result is assigned to the variable total. Count equals len numbers. Here, len numbers calculates the number of elements in the list. The len function returns the count of items in a sequence, like a list, and the result is assigned to the variable count. Average equals total divided by count. This line calculates the average by dividing the sum total of all numbers by the count of numbers in the list. The result is assigned to the variable average. Return average. This line indicates that the function should give back a result when it's used. In this case, it's returning the calculated average. Using the average calculation function. Now that we have the function defined, let's use it to calculate the average of a list of test scores. In the code above, we provided a list of test scores representing scores of students. We then used the calculate average function to calculate the average score and stored the result in the average score variable, displaying the average. Let's print out the calculated average test score.